so we're trying to figure out the dimensions that get passed in to find out where the unit should find its updates and search for its AI for who it should get attacked. So yesterday we got to intersect in 2 dimensions. We're actually intersecting onto 4 dimensions. So let's figure out what's going on here. So it should width and height. This one actually would, because we're actually going 150 over. So if we make this 1200 by 1200, that should do the trick. Still not doing the trick, in fact. I'm still getting 4. So let's take a look. We have okay, so it looks like we're passing in the X and Z, but not the width and height. Oh no, it's we are. Going here getting points. That's the X and Z. So I will inspect X and Z. Test. And this is the world server test. That's not that great. World server test 49. So it's giving us 49, 50, 64, 61, 64. Okay, and then our locations it's bringing back to us is 48, which is correct, and 8,000, which shouldn't be possible. So let's put that there and see what things say. $48. What we could do, I inspect. I inspect. So it's putting us in 3, 4, 4, 4, 3, 5, 4, 5. So it is putting us in a bunch of different places. What is 4950 plus 1200, 6150. And 1600 times 4 is 64. So it shouldn't actually reach it. Duh. So, what do we got? I inspect X and Z. And so 4150.64 came in, and it pasted it into 48.64. Then the right border, 6150.64. Okay. And then 4950.76. You know what? This is what's wrong. We need to floor it. No. Floor. Float floor. There we go-ish. I inspect. Now I think what we need to do from there, because I think floor actually return certain. No, we'll need to round that because it'll be floating point number, and we can't. There we go. So now it only fits into one. So I'm going to drop this down to 68. It's saying that, oh, that's wrong. Okay. Width actually doesn't reach into the other screen. There we go. There we go. Now, this one should get one intersecting dimension. So, I think we've got that one covered. This one here is we need to add the unit. We get the, calculate the dimensions. You may be asking why you might be wondering why, and I'll be asking why I actually split these out, the def calculate dimensions, the get points, dimension containing, away from the gen server, is so that when we add the unit, we actually calculate this first. And then when we update it, that's when we tell the gen server. So it's doing as little processing as possible. So it's keeping the PID unblocked. That's why, if you were curious. So what we need to do is we need to add sure what the plan was with this, but should add unit to one partition. Okay, and so his vision is 80, which isn't very much, so this should be very easily addable. We're just going to stick his position at 40. Oops. I'm going to stick his position at 40. No, 51, something like that, and then the Z position will be one like this. Okay, and so we should get the, when we add the unit, we should get the PID we give it the dimension. Can we so we can do is we probably need to get the, so yeah, we have getting the dimensions. I think that's what it was, what this test was, is test should get PID for PID, yep, should get one PID for which dimension to add a unit to. And this is going to be our world PID to end. Okay, so now we can skip this for now, and we're going to do world server it dims, and we're going to take this one. Put this there, and I'm going to make this a different number. Alright, I need to really refine that. Okay. Okay. Seems reasonable. Okay, so it should, I didn't actually do the math, but it looks reasonable, like it'll actually show up in only one. So, yeah, it should. So get dims, this will give us a, in fact, get dims, let's do get partition, which makes better sense. Partitions. Okay. And what we need to do, this is actually not correct. We actually need to do 4,800. It has to be the exact dimensions, because at this point we've already gotten them. And so from the calculated this stuff, the get dimension containing, so we've already calculated, so we don't want to run the calculation in get partitions. We could, but let's do this way. Okay, so we have to get partitions, and we're going to give it the dimension as a list, and the world PID. Okay, and this will give us part PID. It's going to give us 1. Okay, now to make it we could, I think the pit is all we need. Is there anything here? In our setup, IO inspect. Easy. Define function world PID line 70. Oh. World PID. Okay. So it does put these in. Let's do. We can make an assumption here because it's our test. We can do spawn, and we're going to receive a PID, red PID, red PID. Actually, we need to do send red PID the location, which is the part. Okay. So at this point, we're going to send. This will give us a. Just need to do a send the partition PID, and we're going to give it ourself. And now we're going to receive do the part dimensions, part m, part m. And after 1 second, actually 100 milliseconds, we're going to assert false. Here, we're going to assert that the part dim is equal to our dim. Next test. Test world server test line 70. Script single clause. Is it you? Oh. Elixir send after. We probably want receive. Send and receive, send and receive. that was probably unnecessary, but we'll do 100 assert false. Actually, we could just do no. And fetch, and let's run our test. No match right hand side. That's considered a fail case. Line. Those are line 30. Line 30. Line 30. Reduce world server line. Oh, world server line 30. Server line 30. Okay. And we need to do kid equals. Okay, kid. Alright, it passed. And it shouldn't have. We've implemented it. Did we? Okay, get partitions. Weird. Art kid. Oh, you know what? That's why. Okay, so it's hard to tell if that failed because there was a lot of output on that, so get partitions. Okay, so it just spit out all the dust. So def handle call get partitions and it's a tuple, the dimensions, and from and state. And I'm going to reply with nil for now with our state. No match right hand side of nil line 73. So we can do empty. Okay, that doesn't match, which is fine. And what we'll do is we need to get the dimensions out of the state, which is dimensions partitions. Dimensions partitions, and that actually could be really wrong. Okay, so let's look here. So we got dimensions for all the dimensions, which is a list, and then we have our partitions that are a separate list. They don't map to each other in any way. So what's interesting is our partitions will know its dimensions, but we have no map to it. So we're going to change this a little bit. We're going to set our, what's our initial state, which is here. We're going to make this our partition map. Partition map, okay? We don't need this anymore. And we have our partitions already mapped. So maybe this was okay. Because the partitions are a map. Boom. Yep. Partitions are a map. The dimension as the key is not going to be that great. So we're not going to be able to look it up like that. Let's double check that. Let's IX this. We're going to create a map. Call it the main map. Okay, and then we're going to do main map equals map.put a, actually we'll just create another new map. There we go. And we're going to take our main map equals map.put our main map, and we're going to put the new map with a list. Okay. And then we're going to do the same thing, so it should be the exact same thing. So newer map equals the exact same structure. I'm going to put that newer map. Okay. And it is the exact same. So that's good. So it did do that. Main map enum. So that's cool. So it does pattern match on it. So maybe we're okay. We'll try it out. So this will be our return PIDs like that. And we're going to enum into return PIDs will be this. A map. And we're going to, actually no, that'll be okay. Enum into dims, the list, and a function that gets a dimension. And so that's our return PIDs. I think this is our accumulator. Let's just make sure. Elixir name into so transform. Okay, so we just need to return. So we don't have an accumulator. And so now we need to get the map.get partitions. This is going to be dimensions partitions. And we're going to get the dimension. It should return a single item or nil. So that could be tricky. We'll cover that. Okay, no match right hand side. Empty list. Red PIDs. Okay, argument error. IO inspect ret PIDs nil. So never found it. IO inspect dims. And so we have 16, 16, 48, 64. So that's fine. And then partitions. Okay, so our partitions is nothing. Partitions. Okay. Hmm. 78. So during that business, it had a nil. Was dimensions. So it has the dimensions. Oh. Okay, that's okay. IO inspect. Partitions. Okay, so I think the problem is scope. So if we hang on to this list twice, but I feel like having those dimensions isn't all that useful. It is a startup. So we'll do partitions equals enum dot enum, not going to be an into, probably map, enum map, map join, map reduce. And that'll return a list. That's not what we want. Map reduce will work. Oh no, yeah. into collectible. Yeah, we can just do into. Into it is, again, and we use our dimensions, and our collectible is this. And yeah, this is, how does this work? Turns a key value. Let's do inspect map enum into 1, 2, 3, and this will do get a map and function item and collector map into 1. So we'd have to have item 5. There we go. So that does work. Okay. So there's our starter function, and this is going to be our dim. And it should just update. Whoa. Okay. And then we can take this out, and that's irrelevant. And we're going to return a tuple of dim and pid. Argument error, still not getting it quite right. Take this out, this out. I inspect partitions. Whoa. Start link dim, inspect dim. All of them. Whoa, okay, yeah, it would be. Because it's a two-dimensional list, which is usually array, but what we need to do is we need to enumerate them as two separate lists. Let's take a look at what we got here. Take the first item, take every, take random, take while, to list. It's a numeral to a list, we already have that. We could flatten. Say here, returns a new enumeral depending on the result finding the corresponding numeral. No. Flat map reduce. I think the problem I'm running into is I want to drop every, I want to do this all in one atomic operation, but it doesn't look like it's going to be easy. Chunk, count, dedupe, drop. Each empty, fetch. What's going to happen if we flatten our list? Where's list at? List. Functions. Flatten. Flatten. List tail. 1, 2, 3, 4, 5. I think we can do flattened dims equals list flatten dimensions. That could be okay. Let's inspect flattened dims enum dot count, and we're going to enum dot, this is unnecessary, enum count dimension. I want to make sure that they're the exact same. Too much inspection going on. Yeah, so it flattened it down and we got rid of the duplicates. So that's, no, that's fine. That's 10 by 10. Never mind. That's exactly what we need. So flattened dims. Flattened dims. We're going to go through and do that. And we get our pass now. Perfect. Okay. Beautiful. Okay, now we're in business. So now we should get test should get 4 PIDs for all the dimensions the unit is in. Sorry to end that in a preposition, but it's fine. Okay, do end. Alright, so now we can do essentially this guy. Yank. Put it here. And he is going to live in 4 places. So we're going to do 49, 50, and 67. So that should give us 4 PIDs. And assert let me assume this is good. Assert partition PIDs enum count is equal to 4. And we actually need to do this better. So we actually need to give it dimensions. And this is going to go into the list of dimensions, because that would only return us 1, or actually 0. And because we want exacts, so 64. We're going to make this a list, and put it there, and go back, oops, and move here, and here, and I'm going to go to the last one, So let's go to 48, 48, 48, 64, 64, 48, and 64, 64. That'll pass because that's not the test we want. And there we go. Pass, pass, pass. So that's exciting. So we should add a unit to one partition. Okay, and so this could get, we might actually set up a separate setup so that we can mock it better. I think, let me think about this. We can say setting up dimensions, and this one is create world partitions. Okay, and now this test here should add one unit to one partition. What we're going to do is we're going to end that last one, and we're going to describe adding units. Ooh, use its units to partitions. Do. And our setup is going to be similar to this, just with some few changes. So I'm going to just grab it. I actually think I'm going to grab all of it. Make and put. So that gives us our starting point, and that is it for the day. We're out of time, but we're getting there. I'm getting excited about it. So that's it for today. Happy coding. I'll see you guys tomorrow.